Welcome to Drawing Ray Diagrams for Convex Lens. We have several rays that we can follow and we know exactly how they behave through a lens. The first ray will go parallel out of the top of the object and it will go straight to the center of the lens, and we know any light beam that comes in parallel will be refracted through the focal point on the other side. So this one will go through the focal point and keep going. The virtual part of this ray will follow the ray that went through the lens, and so we can draw the virtual part back behind there. The second most useful ray is the one that goes right through the center of the mirror, and at that point it doesn't get refracted and it stays straight, and so we can tell where that one goes. The virtual part of this ray goes back this direction. The next ray that we know about will be the one that would go through the focal point on the object side and to the center of the lens, and it will go straight out parallel, be refracted, so it will be straight out. And the virtual ray from this one will be straight back. With these three, we can tell exactly where the image is going to be. The image is going to be right where all three of these lines line up. Now, if I would have drawn it better, they probably would have lined up pretty good. But the object is going to be at that point, and so I'm going to draw that in green. It goes from where the lines converge up to the optical axis, and the top of the image is where they converge. So we can characterize this image as real because the real light beams converged, and we can look at it, compare the size. The image is much bigger than the original object, so that's magnified. Okay, and then the orientation is it's upside down to the object, so that it's inverted. And that's our characterization for the convex lens, or we can sometimes call this a converging lens. The next lens we're going to look at is called a diverging lens, or concave lens. And we can follow the rays pretty similar. Now this one, there's only two of them that are very useful, and the first one is parallel to the optical axis, and this one pushes the light beam upwards towards the thicker part of the lens, and it will go up as if it is going through the focal point on the positive side. So the virtual beam will follow that line through that focal point. The other beam that we know exactly how it behaves would be the one that would go through the center, and it wouldn't be refracted, and it would keep going. And of course, the virtual part would go behind. And these are the only two that you need when we find the image. The image is where those two lines converge right in the middle there. This only produces one type of image. It's right here. The orientation is upright, and it is virtual, and it is small. And there you have an example of how to handle the light beams on lenses.